pattern recognition. I am aware that when you were young, you were good at recognizing patterns and answering what is going to be the next. Maybe answer this. 1, 4, 9, what?
16.
16.
Okay. 0, 7, 26.
63.
63.
63, 53. 63. This is okay, this is okay. Then, I mean, I should put you in trouble. For that, अरे मेघराज, अरे मेघराज म्हणून आपल्या वर्गात कोण आहे? Okay. Next pattern 1, 10, 25. Yes, what is your answer? If you recognize pattern correctly, earlier that you have given, you were getting good numbers, and there were many patterns which were difficult to identify, difficult to recognize. And just by understanding the first three numbers, if we are saying that the next fourth number is so and so, I have not got another example. I can always create one example where for these first number, three numbers, I have some other formula, and the other formula will give fourth number different than 46. We can always create three number sequence with two distinct logics, two distinct formulae, and then if somebody is using first, he will get one answer, and the other he will get the other answer. And therefore, these are always problematic questions. I mean, if they are easy like this, unanimously everyone will answer. Unanimously everyone will answer. Designer also has got 16 in his mind, 63 in mind. But then I have made it little complicated and you struggled. But I can always make it complicated. D of n, if I define like this, 2n cube minus 5n square plus 7. Okay, I will have to do some work to get n is equal to 1. Then it is how much? 4. First number is 4. N is equal to 2 gives me 16 minus 20 plus 7. So minus 4, 3. Second number. And if n is equal to 3, 3 3 9 27 and 54 वजा 3 3 9 45 अधिक 7. 9 plus 7, 16. And then if I ask you fourth number, I am going to be cruel with you. 4, 3 and 16, and you want me to recognize the pattern for fourth number? I am not interested. But unfortunately, because you were young and you were required to play with numbers, Some examples of this kind were formulated. If my calculation is correct, I mean, if I put n is equal to 4, I will get one number here. Now that number is going to be greater than 16, but the pattern says first number is greater than third is greater than second. But somebody will say that fourth number should be less than 60. Something like that. Many arguments can be made, and therefore I am raising a question on pattern recognition itself. Are we supposed to recognize the pattern and use it, or I may say, suppose E of n, I write whatever number comes to my mind, maybe I write, say, today is what date? 15th, first number, 6, second number, 2021, third number. And if I ask you fourth number, I am sure nobody of you will waste any second, any time for finding out the fourth number, because it is going to be very difficult. But then I say not only number, but suppose I say the fourth number is what should I say, 1947. Suppose I say the fourth number is 1947, and I say I have got a logic to explain you why it is 1947. And if I explain the logic means I will give you a formula. By which, if you put n is equal to 1, you will get 15. If you put n is equal to 2, you will get 6. If you put n is equal to 3, you will get 2021. And if you put n is equal to 4, 1947. Maybe 1947 is a very good number. We can say fourth number is pi. We have derived pi recently. A rational number. Circumference to diameter. Can I really develop a formula like this when I get to put three numbers like this, and fourth number is, if you put n is equal to 4, you get answer pi. Let us do this. En. First number is 15, second number is 6, third number is 2021, and fourth number, I am predicting that it is pi, circumference to diameter ratio. And Lagrange, L-A-G, एक मिनट ना, spelling चुका है, if it is there in this book, I will get it right. Lagrange, L-A-G-R-A-N-G-E, Lagrange, Joseph Louis Lagrange, 1736 to 1813 AD. Or 1813 AD. How old this technique is, just imagine. So Lagrange was the first. What he did was, En is equal to you are going to substitute n. For 1 it is 15, for 2 is 6, for 3 is equal to 2021, and for 4 it is pi. Is that right? So he said, let me write it down, n minus 6 into, sorry, n minus 2 into n minus 3 into n plus 4 upon 1 minus 2 into 1 minus 3 upon 1 minus 4 times 15 plus n minus 1 into n minus 3 into n minus 4 upon 2 minus 1 minus 3 2 minus 4 times 6 plus, I will have to make it little smaller, 56%, shift that side. Next, n minus 1, n minus 2, n minus 4 upon 3 minus 1, 3 minus 2, 3 minus 4 times 2021 plus n minus 1, n minus 2, n minus 3 upon 4 minus 1, 4 minus 2, 4 minus 3 times pi. This is the formula. This is the formula by which you will get the required answer. Let us put, if we put n is equal to 1, observe this, n is equal to 1, so 1 minus 2 upon 1 minus 2, 1, 1 minus 3 upon 1 minus 3, 1, 1 minus 4 upon 1 minus 4, 1. So 1 multiplied by 15 is 15. And if I put in the second, n is equal to 1 here, this bracket is 0, the entire block is 0, n minus 1, entire block is 0, n minus 1, entire block is 0, therefore 15 survives for n is equal to 1. If we put n is equal to 2, first block itself is 0 because n is equal to 2 makes it 0. N is equal to 2. 2 minus 1 upon 2 minus 1. 2 minus 3 upon 2 minus 3. 2 minus 4 upon 2. 1 into 6, 6. N minus 2, 0. N minus 2, 0. And therefore, the fourth number is going to be 5. Okay, this is called Lagrange's 0, 1 block. Lagrange's 0, 1 blocks. Because these blocks are designed in such a way that if you want that term to survive, it will be equal to 1, else it is going to be 0. So these are the blocks which are important. These numbers are not important. You can put whatever you want. Okay. But then, I mean, fun part of it is one part of the story. But what is the real application of this? Real application of this is, as I said, this En is going to be sum A3 n raised to 3 plus A2 n raised to 2 plus A1 n plus A0. It is going to be an algebraic expression after simplification. And in this expression also, if you put n is equal to 1, you will get 15. If you put n is equal to 2, you will get 6. And if you put n is equal to 3, you will get 20, 20. And if you put n is equal to 4, you will get pi. That will happen up to this. However, fifth number is fixed now. We don't have choice for fifth number. Because the formula is fixed, fifth number is fixed. What is the application of this? Okay. Application is very, very important. Now, I am not sure whether you are performing some experiments in laboratory or not, but normally those are just for academic purpose. Suppose we are collecting data from say March 2020. In India, how many are affected by COVID? This one. How many in April? This. How many in... So suppose you end up having some data with you, some data. Of course, it is not going to be continuous curve like this because, okay, so if it is not, then why should I draw it? Okay. March 2020, this is the number. April, this. May, this. June, this. July, it was less in India. August, still less. September, October, November, December, January, February, March, April, May, June. No, it is rapidly increasing. Here, and it went beyond the earlier one, and now we are, suppose here, this is our June 2020. Okay, so we have got a discrete data with us, and whatever is the behavior of this data, we don't know what kind of curve is this going to be if joined. Now, between the two, you can assume that it is from March to April, you can assume that every day it is going equal. So you can join with straight line or a curve, something like that. It is not going to happen that 1st of March it is here, then 15th of March it is here, and 30th of March it is here. It is not possible like this, and therefore there is a fashion to join this by a smooth curve, and those who are involved in statistics, they require this kind of curves every now and then. And therefore, if you have data for last 14-15 months, you can predict what is going to be July, what is going to be August, what is going to be September. Wishful thinking we can do, and there could be. Now, if I apply this Lagrange 0 1 block and I have data for 14 months, and I wish to predict what is going to be in 15th month, then it is going to be reasonably correct if I apply this, because all of a sudden it is not going to change like this. So if these numbers are known to me, suppose first month of operation, second month of operation, third month of operation, fourth month of operation, if these numbers are known to me, A, B, C, D, E, then this Lagrange 0 1 block give me the formula. This Lagrange 0 1 block will give me the formula to find out what is going to be the next month. Or this formula is going to be very useful to find out what is 15th of June last year. What is 15th of June 2020? And I am comparing 15th of June somewhere today, 15th of June. So to get idea about the in-between points, nobody will stop me to put n is equal to 3 by 2 here in this formula, because I want to know what is 1.5 reading. If this is first reading, this is second reading, what is 1.5th reading? Divide 3 upon 2th reading. I put 3 upon 2, I get it. It is going to be reasonably correct. If I want 5 upon 2 reading, 2.5, what is the reading going to be at 2.5? N is equal to 2.5. This is going. So this is called curve fitting. C-U-R-V-E. Fitting. There are many methods to get the curve. The two-dimensional geometry that we are going to study, we will study the basic curves. In 11th standard, you will see some advanced curves like parabola, ellipse, hyperbola. But then if the curve is not well behaved, it looks like this, then can I find out algebraic expression of this curve, so that if I put x value is equal to this, I will find out what is the y value. And therefore this curve tracing, curve fitting is extremely important, and Lagrange 0 1 block gives you the first curve, algebraic expression for the geometric curve that you have reasonably accurately. That is the application of this.
Tell me, sir.
Let us solve the problem. Find the suitable formula for Bn. Find the suitable formula for Bn. Okay, what is Bn? B1 is equal to 1. No, sorry. Mm, Find the suitable formula for Bn. No, I mean just ignore this. Let me write down one more. Find the quadratic equation. Denote it like P of x is equal to ax square plus bx plus c, such that P of 2 is equal to 7, P of 6 is equal to 1, P of 8 is equal to 5. Okay, now let us solve this problem and you will understand what we are trying to do. Now, after we learn the theory of quadratic equation, we will come to know what this is, but I hope you must have solved some quadratic equation by now. What is this saying? This problem is saying that on x-axis 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. Okay. So this is 2, 3, 4, 5, 6. This is 6, 7, 8. This is 8. The value of the function when we put x is equal to 2 is 7. This is the point. When we put x is equal to 6, we get 1. This is 7. This is 1. And when we put 8, we get 5. And now what the question is saying is you find out ax square plus bx plus c such that if you put x is equal to 2 in this formula, you get 7. If you put x is equal to 6 in this formula, you get 1. And if you put x is equal to 8 in this formula, you get 5. This is a standard problem. And if you know simultaneous equations, it can be solved by, say, suppose if we put x is equal to 2. I am showing you general, another method of doing it. If I put x is equal to 2, the answer is going to be 7. 4a, x is equal to 2. Plus 2b plus c. This is first expression that I get. Second expression is 1 is equal to 6, 36a plus 6b plus c, and 5 is equal to 64a plus 8b plus c. I hope whether you can solve these equations or not is a question, but I hope one can solve these three simultaneous equations in three unknowns and you will come to know A, B and C, yes or no, and you can put it back in this and of course you got the required equation. Using Lagrange's 0, 1 block, let us do it. Let us do it. P of x is equal to, now observe this very carefully and then we will simplify also. If I put x is equal to 2, I should get 7. Okay. So x minus 6, x minus 8 upon 2 minus 6, 2 minus 8 times 7 plus x minus 2, x minus 8, 6 minus 2, 6 minus 8 into 1 plus x minus 2, x minus 6 upon 8 minus 2, 8 minus 6 times 5. Okay, we are done. This is what it is. If I put x is equal to 2, this is 0, this is 0, I get 7. If I put x is equal to 6, this is 0, this is 0, I get 1. If I put x is equal to 8, this is 0, this is 0, I get the third. Now it is easy, not really easy, but because I am saying that we can do it, let us do it. This is equal to x square minus 14x plus 48 divided into 7 upon, how much is this? Minus 4 minus 6 अच्छा 24 plus x square minus 10x plus 16 into 1 upon 4 दूने 8 minus it plus x square minus 8x plus 12 into 5 upon 6 दूने 12. Okay. So what is the coefficient of x square? 7 by 24 minus 1 upon 8 plus 5 upon 12. That is the value of a that you have there, plus what is the coefficient of x? 14 into 7 minus 14 into 7 upon 24 plus minus 10 into 1 upon minus 8 plus minus 8 into 5 upon, well, that is the coefficient of x. And what is your constant term? So 48 into 7 by 24. Why I have closed the bracket? Okay, first one. Then minus 2 and then plus 5. Good. Now the only difficult job is to get those 3 brackets done and let them be fractions. Now at this point let me do it, even if my age is not allowing me to do. 24 7 8 24 12 दूने 24 plus again 24 हाँ 14 14 14 7 98 minus 98 8 3 24 minus 3 minus 10 plus 30 12 दूने 24 8 दूने 16 पंचा 80 times x 24 दूने 48 7 दूने 14 वजा 2 12 आणि 5 17. There 17 minus 3 14 upon 24 7 by 12 x square. I am wrong because I am very bad these days in algebra. Minus 98 plus 50 is 148 upon 24. 12 6 37 by 6 x plus 70. I don't think I will get the correct answer because I must have messed it up somewhere or the other. The smallest number x is 2. Let us cross check. So if x is equal to 2, we get 7 into 4 upon 12 minus 37 into 2 upon 6 plus 17, which is equal to 3 द्वारा. I'm not clearing denominator also. 7 by 3 minus, this is 6, so this is 3, and 37 upon 3 plus 17. Array, am I getting 7? Is the answer 7?
Yes, sir.
Yes, sir.
So my calculations are correct.
Yes, sir.
This is your answer. P of x. कळलं का पुरोहित? Having understood that there can always be given a formula for destroying pattern, let us start learning pattern. Normally, the sequence of numbers A1, A2, A3, dot dot dot, AN is denoted by, I think I have told you this, AN is a sequence of numbers. Okay? What we had done in functional, no, generating functions. Okay. Now, AN is said to be an arithmetic progression if and only if Tn plus 1 minus Tn is constant. Where Tn is nth term. This is basic definition of arithmetic progression. You might be all aware of that. The constant is known as common difference. Constant is called of an AP. Instead of writing arithmetic progression, we will write AP. So, another way of representing arithmetic progression is A plus D, A plus 2D, A plus 3D, dot dot dot. Hence, nth term is equal to A plus
minus 1.
D. A is first term. So if we know two things, one, to fix an AP, we need A and D. First term and common difference, we can fix the arithmetic progression. So if some additional information is given to you, you should arrive at what is first term and what is common difference. That means you have identified the arithmetic progression. So before we take the examples, let me do some theorem. Let A1, A2, AN be an AP. Let D be common difference.
So D, letter B or BE?
I have written it. You read this, na? D be the common difference of AN. Let K belong to R. K belongs to real number. For each natural number n, let Bn is equal to An plus K. And Cn is equal to K times An. Then 1 Bn is NAP. 2 Cn is NAP. Do you understand?
Yes, sir.
If one arithmetic progression is given and to every term we add one more number like k, then whatever new sequence that you get is also an arithmetic progression. If one arithmetic progression is given and if we multiply every term of that arithmetic progression by some constant k, multiply by k, then whatever new sequence that we get is going to be an arithmetic progression. We have to prove this because this is here. Okay. As far as the first part is concerned, it is given that A1, A2, A3 is an AP. Okay, that means n plus 1 minus an is equal to given common difference D. Okay, let us add k to both these terms. This implies an plus 1 minus an plus k. Okay, so we are adding k to both sides. One we are adding, another we are subtracting. Therefore, it is also equal to d. So this implies bn plus 1 minus bn is equal to d. Yes, and hence by definition bn is AP. Similar here, an plus 1 minus an is equal to d. Here times n, let us do it, k times an plus 1 minus an is equal to kd. So k an plus 1 minus kan is equal to kd, which is Cn plus 1 minus Cn is equal to Kd, where K is real number, that means it is constant, D is common difference. Hence, by definition, Cn is an AP. Simple. Theorems. three question. Consecutive terms. In an AP, is equal to 21 and sum of their squares is 179. Find these terms. We will assume a minus d, a plus d as these three consecutive terms, and therefore when you add them you get 3a is equal to 21, a is equal to 7. Middle term is 7. Quick. Then a square minus 2ad plus d square plus a square plus a square plus 2ad plus d square is equal to 179. This implies how many a squares? 3a squares. How many d squares? Plus 2d squares is equal to 179, out of which a is known to me. 49 into 3, 27. So 2d square is equal to 179 minus 9 3 27 7 2 4 3 12 13 14 is equal to 2 3 32, and therefore d square is equal to 16. Therefore d can be plus or minus 4, and therefore if middle term is 7 and if d is 4, then the earlier term is 3, next term is 11. If middle term is 7, if d is minus 4, first term is 11, third term is 3. This is your complete answer for 6 marks and not 3, 7, 11. You have to be alert. This was easy. We have 20 minutes. Let me give you a bigger problem. Sum of the 5 consecutive terms of an AP is 65 and sum of their squares is how much? 9. Sum of their square is 935. Find the terms. Answer of earlier question is 7, 10, 13, 16, 19 or 19, 16, 13, 7. Next question. And in an AP, T12 is equal to 10. T20 is equal to 140. Find T101. Simple. Yes. Answer of this question is, it seems. How will you do this? 12th term is 100. That means A plus 11D is equal to 100. 20th term is 140. Therefore, A plus 19D is equal to 140. Subtracting 1 from 2, we get 8D is equal to 40. Therefore, D is equal to 5. If D is equal to 5, then A plus A is equal to 100 minus 55, which is equal to 45. So if A is 45, so T101 is equal to 45 plus 100 times D, which is 5, makes it 540. Simple. Next problem. Last problem of the day. Question. T6 is 10. T10 is 90. Does this AP contain? Does this AP contain what? 200 as its term. Yes or no? Should be the answer. Okay, the answer for this is no, for obvious reasons. You can find out the term which is contained in this particular AP less than 200, greater than 200, and therefore 200 is not there. That is where we stop for the day. Okay.
Sir, in next